On December 26, the online video captured the suspected test flight video of China's sixth-generation aircraft, accompanied by J-20. This news is like a heavy bomb, which instantly ignited the passion of military enthusiasts and people from all walks of life. This event has caused a huge stir in the aviation industry. The stealth capability of the new fighter jet far exceeds that of the current fifth-generation aircraft, and its huge size and complex design make it an important milestone in the history of the development of the world's fighter jets. According to the video, the length of the new aircraft is basically the same as that of the J-20, but the wingspan is significantly larger, possibly more than 15 meters. Its main landing gear adopts a longitudinal twin-wheel design, similar to that of the MiG-31 and Su-34, which means that the maximum takeoff weight of the new aircraft may exceed 45 tons, according to footage taken by netizens. The mysterious new fighter jet has a huge nose with large windows of wave-transparent material and complex aerodynamic surfaces at the trailing edge of the wings, suggesting that it will need to meet very high air control performance requirements. The new aircraft appears to have 3 air intakes, including Gallet intakes on both sides of the fuselage and a dorsal intake on the back of the fuselage, which may provide air intake for a third engine. Overall, the new aircraft is very large, meaning its range and bomb load could be excellent. What are the features of the Gallet intakes? The design concept of the Gallet intake and its use in military fighters is becoming a much anticipated focus in the world of aviation technology. At first glance, one might associate it with the engine intake configuration of the Russian Su-57 fighter jet, raising concerns about its potential radar wave reflecting characteristics. However, these concerns are often based on a one-sided understanding of intake design. In fact, the Gallet intake makes clever use of the scientific principle of supersonic surge pressurization. By skillfully separating the supersonic surge, this design has been perfected to significantly increase inlet pressure at supersonic speeds. It is unique in its ability to give fighters superior performance at high speeds. However, the design also comes with the challenge of high structural complexity and weight. Given the stringent lightweight requirements of fighter jets, the development of the Gallet intake required a careful trade-off between performance and weight. It is important to note that the application of the Gallet intake is not limited to a specific aircraft type. For example, it is used in the F-18 Hornet. However, because the F-18's intakes do not have an S-shaped layout, its engine blades are more conspicuous in appearance. In contrast, the F-22's intakes cleverly hide the engine blades through the S-shaped design. Some sources say that the intake channel of the Su-57 fighter jet also adopts the Gallet design, but it seems to be lacking in the concealment of the engine blades. Its intakes have an upper S-shaped layout and incorporate a DSI-like deformation assist design on the outside of the horizontal plane. This design may be a trade-off to ensure consistent engine performance. However, there is still some uncertainty regarding the exact details of the Su-57 intake design. In summary, the Gallet inlet, based on its supersonic surge pressurization principle, shows mature technical characteristics, but also faces the problems of complex structure and large weight. The application in military fighter jets requires a careful balance between performance and weight, and the research in this field will remain an important direction in the development of aviation science and technology. Who is better, the Gallet air intake or the J-20's clam air intake? When comparing the Gallet intake with the J-20's clam intake, it should be analyzed in depth from several dimensions, such as stealth performance, aerodynamic efficiency, structural complexity, and weight. First of all, from the viewpoint of stealth performance, the Gallet inlet adopts the S-shaped design, which can effectively conceal the engine blades and reduce the radar reflection characteristics, thus enhancing the stealth performance. Although the design mitigates the risk of radar wave reflection to a certain extent, its cross-sectional shape may still have certain reflection hazards. Comparatively speaking, the J-20's clam-type air intake is more outstanding in terms of stealth performance. The design of its non-attached surface layer partitions significantly reduces the radar reflection surface, and combined with the unique bulging structure, it further reduces the radar detectability. Therefore, the DSI inlet has obvious advantages in stealth capability. Secondly, analyzing from the perspective of aerodynamic efficiency, the Gallet inlet is based on the principle of supersonic surge pressurization, which efficiently enhances the airway pressure during supersonic flight and shows good performance. However, at certain speeds, its efficiency may be inferior to other designs. The clam intake, on the other hand, smoothly introduces airflow into the intake ducts through the regulation of multiple complex surges, thus maintaining a low pulsation frequency under different intake conditions. This design is not only conducive to the stable operation of the engine, but also enables the J-20 to show excellent aerodynamic performance in supersonic cruising and low-speed supermaneuvering. Lastly, regarding structural complexity and weight, the Gallet intake is a more complex design that includes a surface layer isolation device and other auxiliary systems, which increases the empty weight of the aircraft and also raises maintenance costs. In contrast, the clam intake eliminates many of the complexities and simplifies the design, resulting in a significant reduction in aircraft weight and improved maneuverability and fuel efficiency. In conclusion, although the Gallet air intake is technically mature and can be reliably used in fighter jets, the J-20's clam air intake shows unique advantages in terms of stealth performance and aerodynamic efficiency. With the development of technology, the subsequent validation and optimization of the clamshell inlet will open up wider prospects for its application in modern fighter aircraft.